Our final thought today is, what is it that we're creating when we create an interpreter? Well, we're creating a general computing machine. So here's an analogy. Think of programs as defining little machines by laying out the procedure by which we evaluate some input to give some output. So the program specifies the logic of some computational device. So if we create a device that computes factorials, well, it might look like this, where it says, if the input is 1, then we just have 1. Otherwise, we have to multiply the input by 1 minus the factorial of the input. And factorial here, of course, is just another copy of this computational device. So 5 comes in, 120 comes out, 5 factorial. Well, interpreters are like general computing machines. So the interpreter takes in as input any piece of code that tells it to simulate any particular machine that we want. So the scheme interpreter might take in 5 as the input, but also the source code that tells us how to compute the factorial. And it uses both of these things together in order to create any sort of computation that we wish. For instance, computing 120. So our scheme interpreter that we've built, or we are in the process of building as your project, is a universal machine. It can perform any computation we wish, depending on how it's parameterized by the input source code that's given to it. So think of it as a bridge between the data objects that are manipulated by our programming language and the programming language itself. It's the thing that puts them together. Internally, though, remember that it's just a set of evaluation rules. An interpreter is nothing more than a program.